Alright, we are doing a review on sequences and series, and here we have a couple sequences that are listed for us, and we have to determine if they're arithmetic or geometric, find the term named, the explicit formula, 3 terms after the last one given. Okay, so after 29, we want to know 3 terms, and then we also want to know the 23rd term, I think. Yeah, we need to know the 23rd term. Okay, and so let's first look in between the 2 and the 11, and I would first start with arithmetic. Okay, so if I add 9, I get from 2 to 11. If I add 9 more, I get from 11 to 20. Add 9 more, get from 20 to 29. So that tells me that this is an arithmetic sequence. Which means that it has an explicit formula that looks like this. The difference times the number of terms plus a sub 0. Okay? We have just established that the common difference is 9. And if I want to know the 0th term, that would be whatever comes before the 2. So what I should do is I should subtract 9 from 2. Okay, so if I'm going forward, I add 9. If I go backwards, I subtract 9. 2 minus 9 gives me negative 7. And once I have that, I'm ready to plug those things into my explicit formula. I have 9 times n minus 7. And just for the sake of education, let's just real quickly, I'm going to show on a graph kind of what this looks like. Okay, if we had 1, 2, 3, 4. Okay, this isn't going to be the best of graphs, but I'm going to go by tens. Okay, so if this is if these are term numbers 1, 2, 3, and 4, then the first term is 2. It's about right there. The second term is 11. Third term is 20. Fourth term is 29. Okay, and this should look familiar to you. It should look like a linear function. Okay, but remember with sequences, we don't have the line, we only have each individual point on the integer values for n. That's why we use n instead of x. Okay? But the same principle kind of applies here, is that the slope of this line is the rise over the run. Okay, so we rise 9 and we run 1. And so if we were writing the equation for the line, the slope would be 9 over 1, or just 9. Okay? So we'd have like 9x. Okay? But we also would be looking for the y-intercept. And if you go back on this line, you would find a y-intercept of negative 7. That's what your b value is. So it would be 9x minus 7 equals y. And I just want to show you that this is the same as our arithmetic sequence. We've just replaced the y with a sub n and the x with n. Alright, so there's our explicit formula, just like a linear function, but just a little different notation to show that we use integers. Okay. We're going to use kind of a recursive formula so that we can get these next 3 terms. And that's just what you do, what you're doing in your head when you say, okay, plus 9, plus 9, plus 9. That's the recursive formula being played out. So 29 plus 9 is 38. 38 plus 9 is 47. 47 plus 9 is 56. Okay, so there's the next 3 terms. And the last thing, we need to find a sub 23, the 23rd term. Okay. So that's what I put in for n. N is just 23. So I do 9 times 23 minus 7 is a term 23. So that is 180, 207 minus 7 is just 200. So the 23rd term is 200. Okay. And that's all there is to that one.